Good afternoon, everyone. Welcome this afternoon. I'm pleased to present James Blair, hacker and sysadmin. He's currently working on OpenStack, and from what I can gather, improving the development process. I'm not sure if that's true or not, but we'll soon find out.
At least changing.
Oh, at least changing it, okay.
We can all agree on that.
So without further ado, James.
Hi, my name is James Blair. I'm on the infrastructure team for the OpenStack project, which means I spend my day not working on OpenStack itself, but trying to make it so that the 500 people who do work on OpenStack can get their jobs done. Today I'm going to be talking about a particular part of our workflow called Zuul, which is something that we wrote in-house. I'll talk a little bit about the OpenStack development process in general, since it ties into it pretty tightly. A little bit about project gating in general. That's roughly the idea that we don't let any changes land unless they pass tests. And maybe a little bit about the Jenkins API, which is and other things that we use to actually get all this done. But real quick, in case at the end of a week where, my goodness, how many OpenStack talks have there been? Yeah. In case any of you don't know what OpenStack is, it's this bit of open source software that lets you build public and private, public or private clouds.
Public and private.
Yeah. So who knows what it encompasses, really? Only the board can say. But it involves compute modules, networking, storage, perhaps other things as well. The idea is basically, if you can spin up virtual or possibly in the future real servers through APIs based on this, or store objects, store data, manage networks, all that sort of thing. So it's how that applies to this is it's a pretty complicated project. In fact, it's composed of quite a number of projects that all behave fairly independently, but at the end of the day, we want them all to work together. So actually, a lot of the complexity of what we're doing in the CI environment is about getting all of these projects to build together and get tested together, at the same time maintaining their ability to develop on their own individually. OpenStack has a large number of contributors, 503 the last time we counted. Most of those come from companies where they're paid to work on OpenStack, full or part-time. Over the past few years, we've been getting just a huge influx of people. It seems every day there's somebody new working on the project. So a lot of our focus has been automating as much as we can to try to get their onboarding done quickly, as well as help them fit into the project well. The code quality from all these people varies greatly, and we want to accept good contributions from everybody, but we don't want to burden the core developers with having bad changes land and disrupting their workflow. So we're building a lot of developer automation to try to make things consistent and to facilitate new people coming on board without disrupting the existing developers. So a big tool in our toolbox for that is the gated trunk. So that means that before any change lands in the repository, it has to pass unit tests, code style tests, integration tests, anything else we want to throw at it. By automating all of this, we make sure that developers can merge new changes from new people with a high degree of confidence. You don't have to know that that person has, you don't have to really know their history. You don't have to know whether they can be relied on to have run the unit tests before they even sent you the patch. You don't have to run them yourself every time you want to accept a patch from somebody. There's a system that does that for you, and by making it egalitarian so that everybody's patches go through this, it sort of democratizes contributions to the project. But as a developer, it's a really big help to know that you can check out the latest copy of the tree and know that it works at least as well as the unit test suite can tell you whether it works. And you can just start working on your new change and go from there without having to fix somebody else's bug to start with. So here's just a little bit more about our automation. It's a screenshot of the actual page with all of our jobs that we run in Jenkins to make sure that these tests run. Is actually getting quite large at this point. We have something like 450 jobs in Jenkins, most of which are these gating check jobs that run unit tests and integration tests and things like that. But Jenkins is the tool that we use to actually run all of these tests. But what you'll find out is that Jenkins isn't the interface that developers use because of the fact that because of the workflow that we've set up, developers actually interact with our code review system much more than Jenkins. So we have Jenkins on the back end running all of these jobs, but it reports its results to Garrett, our code review system, which is actually where developers see, did this job pass for this change or not. So a quick overview of the workflow for a developer. You'll probably be writing code in a virtual env. We've set this up so that it's really easy to get started with any project and get all its dependencies. I should say the OpenStack project has favors the Python language. All of the OpenStack projects are written in Python. So virtual env is a tool that lets you download Python dependencies into a little isolated environment on your machine. So you normally set up an environment with the project that you're working on in a virtual env, write some code, and ideally test it, not strictly required. But then you'd use a tool that we wrote called Git Review to submit that to Garrett, which is our code review system. At that point, Zuul is going to start running the patch uploaded checks so that developers can get quick feedback on, hey, does this change even pass unit tests? So core reviewers, when they're going through the code review system looking for new changes to potentially merge, they can look at the results of the tests shortly after the patch is uploaded, and they can see, well, is this change, it doesn't even pass unit tests. I'm not going to bother reviewing the code. Just let the developer fix that first. So we try to get fast feedback to developers and reviewers and run these things as soon as something's uploaded. Assuming it does pass checks, a core reviewer will come along and do peer review on the code. We have policies for the OpenStack projects that we need two votes from core reviewers before a change should be merged. That's not actually implemented technically. That's more of a human policy that the core reviewers should observe. Once that's met, somebody decides to actually pull the trigger and approve the patch. And at that point, we run through the pre-merge checks, which are pretty much the same as the checks that we ran when the patch was uploaded. But in the intervening time, the repository almost certainly will have moved on. And so what we want to do is test, well, if we merge this change into the state of the repository as it is right now, is it going to pass tests? And assuming it does, then we merge it. And if it doesn't, then we kick it back to the code review system and say, hey, something's changed. You need to take another look at this. So a little bit more about Gerrit. It's a standalone code review system written in Java by Google to help with the Android project. It's really flexible. It has a number of integration points. You can have hooks, like standard Git style hooks. You can do JSON queries against it. It has an event stream that you can connect to over SSH, and it'll just spit JSON data blobs out at you every time something interesting happens, so you can get real-time notifications. And it has extensible review categories. So you can have this matrix of, has this change been verified? Has it gone through code review? Has somebody approved it? Those are the three that we have. You can add as many more of those as you want. And then, of course, different people or entities or bots or whatever can vote in any of those categories. So just really quickly, the states that a patch go through in our workflow is it gets submitted to Gerrit. Then we run the pre-merge checks and decide whether it's verified. The core reviewers review it, and then one of them might accept it, and then finally it gets merged. Gerrit itself has a number of triggers that we operate on, and I'll show you examples of usage of these later. But we get a trigger when a patch set is uploaded. We can trigger when a change is merged or when a comment is added. Something I left off here actually is we can get a trigger event when a ref is updated. So if somebody tags something and pushes that tag up to the repository, we can act on that as well. So here's what the feedback in Gerrit looks like. This is actually just a partial screenshot here, but you can see that over time, a number of people weighed in on, asked some questions about this, said, I like this, I don't like this, that sort of thing. All of these actually expand so you can read more. But here at the bottom, you can see that Jenkins weighed in and said, hey, this passes all of the tests. It passes it'll actually merge. It passes PEP 8, it passes the Python 2.6 and 2.7 versions of the unit tests, and then it passes our integration test as well. So we run a couple of types of jobs in Jenkins. I've already basically mentioned the check and gate jobs. Those are where we run unit tests, integration tests, and style tests on the patches. The check jobs is what we call them when we do it when a change is uploaded, and the gate jobs are basically the same jobs when we're actually trying to merge a change. We also do post-merge jobs in Jenkins. We build documentation and upload it to the doc site. We build tarballs, and we publish things to PyPy. All of those are we do that with the same systems. We just do those jobs after a change is merged instead of before. So we started a lot of these ideas just by using the Gerrit trigger plugin with Jenkins. And if you're already using Jenkins and Gerrit, the Gerrit trigger plugin is still a great way to get started. Just starting to trigger some Jenkins jobs from Gerrit. But what we found is that as we increased the complexity of the OpenStack project by adding more projects, by adding more and more changes and things like that, adding more tests that we needed to run, that we weren't able to express the kind of complexity that we needed to with the Gerrit trigger plugin. So we wrote Zuul, which is a general purpose system that manages truncating as well as the rest of our automation. It's extremely flexible. It actually, I'll show you some of the primitives later, but it has very little of our workflow built into it. We set up a number of primitives and then we built our workflow on top of it. The biggest change, though, is that Zuul lets us test serialized changes in parallel. and that merits a little bit of explanation. Earlier I mentioned we want to test every change before we merge it into a project. The most correct way to do that is to literally, test a change, merge it, test the next change, then merge it. Our integration tests are taking about an hour to run these days, and you can imagine that, clearly that means that if you set up a system that did that, you could only merge 24 changes in a day, and we're merging many more than that. So what we do with Zuul is we have a system that uses speculative execution to basically test lots of changes in parallel, but do so after having set them up in a sort of virtual queue of changes where they depend on each other serially. So we virtually serialize them, but we actually test them in parallel, and we assume that all of the tests will pass. If they do, that means that we can merge all of those changes at the same time. If that assumption is wrong, then that means that we have to cancel some of those tests and rerun them with the new information as to what can actually merge. So here's a little visual simulation for those of us who can prefer visual learning as opposed to textual. Here what we've got is, you can imagine that these two dots represent the commit on the head of two different repositories. So imagine you're looking at a little git DM graph, and these are the head commits. So then somebody goes into Gerrit and they approve a bunch of changes in quick succession. So they approve a change to Nova, another change to Nova, then a change to Keystone, and then another change to Nova. These two projects, Nova and Keystone, they're different projects, but we run them together in the integration test, which means that either one of those could break the other project. So we actually need to serialize changes to both of those projects in one queue. So what Zuul does is it notices that somebody's approved the first change, and then the second, and then the third, and the fourth, and so it makes this virtual queue of changes that need to merge in this particular order. It then tells Jenkins to start running tests on all of these changes at the same time. So it'll say run 4 tests on the Nova changes, and there's only 3 tests for Keystone. They all take different amounts of time, but eventually they all finish, and all of the tests for the first change to Nova pass. The second change on Nova, before it ran those tests, what it did was it merged the first change and then merged the second change into the working tree on the Jenkins node, and then ran the tests for Nova again. So this is actually testing, over here, this is testing both change number 1 and change number 2. For Keystone, same thing, it'll actually, on the copy of Nova that it installs in the integration test suite, it will have merged changes number 1 and 2 before it started Nova, and then we'll have also merged the change number 3 into Keystone, and then ran a test. Here in our simulation, one of those tests has failed. Likewise, it's for change number 4 to Nova. All of the other 3 changes have been merged, and this one also now has a failing test. So once these results come in, Zuul starts analyzing this, and it says that all the tests passed for change number 1, so it's good to merge, and it gets merged on there. Same thing for number 2, they all pass, and so it can merge. So at this point, it sees number 3, and it says these changes didn't pass, these tests didn't pass, this change has failed, and so it can't merge, it just gets kicked back to code review. The interesting thing about this is that number 4 was tested under the assumption that number 3 was going to merge. It didn't, so Zuul then has to restart the test for number 4 again, just based on the current state of the repository. And this time it succeeds. So clearly what had happened before is that the change to Keystone had broken Nova. But since that didn't merge, this now works again, and so it's safe for it to merge. So that's what I mean when we say that we use speculative execution to to test these changes in parallel. In practice, we actually see this. We see quite a number of changes stack up in the queue and finish about the same time, and oftentimes we see 10 changes effectively merging at once. John?
Can I ask a clearer question?
Sure.
Just to make sure I understand what you said, please correct me if I'm wrong. If you had, these are the changes that were queued individually for the projects, correct? So Nova 1, 2, and then Keystone. Just in the order that the developers push Git review, correct?
Right.
So if one,
Or the order they were approved.
yes, yes, I'm sorry, that's what I meant. The order the core devs click +1 approve.
Right.
At this point, if all would be tested concurrently, but if, say, for example, Nova 2 had failed, then both of the other two would have to be retested.
Yes.
So if it's kind of like a branch miss prediction sort of thing.
Exactly.
It's expensive.
Yes. Yes, it is.
Okay, that's what I need to know. Thanks.
Since we're working on cloud software, and we've got a bunch of cloud companies working on this, they give us resources at little or no cost. So we actually consume quite a number of virtual machines, particularly in the integration test, to do this. Basically, it boils down to, in our situation, we'd rather keep things moving quickly, and so we go through more resources than strictly necessary in order to do that. I understand that might not apply to everyone, but there are things that you can do with tuning, how many Jenkins slaves you have available, that sort of thing, to tune exactly to what degree the parallelism happens.
What's the ratio of good to bad changes?
What's the ratio of good to bad changes? I don't have a number, but I can say that in general, most changes pass, which is why this works. So in fact, if you've been thinking about this, the best case of this algorithm is that all the changes pass all the time, in which case we can merge as many changes in parallel as we can merge as many changes simultaneously as we can test in parallel. So basically, as many machines as we can run tests on is how many changes we can merge at once. So that's quite a good case. The worst case for the algorithm is that everything fails all the time, in which case that basically just sends us back to testing serially. The thing at the head gets tested, it fails. The thing behind it gets promoted, it gets tested, it fails, and so on. So our worst case is actually the system that we started with the Garrett trigger plugin, which is everything tested serially one at a time. In practice, my feeling is that most changes pass, and maybe 1 out of 10 or 20 or something like that fails.
Because remember, this is the second time we've tested these.
Yes, that's true. So I mean, in some sense, you could in Garrett look at the -1 from Jenkins and say, yes, this is ready to merge. I'm not sure why you would do that. So generally, people should only be approving changes, if this is already past the tests in Jenkins. So here's a little bit of how we configure the system. It's configured with a YAML-based configuration file where we can sort of lay out. I should also say that conceptually it's broken up into pipelines. So I've just been focusing on the gate pipeline, which is changes as they're trying to get merged. We have other pipelines, the check pipeline, the post pipeline, other things that I'll show you later. So anyway, in this configuration file, you set up a pipeline, you give it a name, you tell it whether it should pay attention to dependent changes or not, whether it should try to do that virtual serialization that I was talking about, or if everything in it is truly independent and has no relationship to each other. So that's the case for the check pipeline. We say that every change is independent. It doesn't matter, no other change that you're testing at any given time affects these results. So just when you get a patch, go test it and then report the results back. So we configure what actually triggers action in this pipeline. So here we say that the patch set created event should trigger the jobs that are defined for the check pipeline. And then we tell Zuul what to do on success or failure. If the tests succeed, then report back to Garrett with a +1 verified vote. If they fail, give it a -1 verified. Zuul doesn't really, it has no idea what verified or patch set created or any of these things mean, or check. These are all, these actions just get passed into Garrett verbatim, so whatever you want Garrett to do, you can put it in here. Whatever Garrett event you want, you can put here. So like I said, this isn't, none of this configures none of these things have a behavior or action built into it. We define all of that in the configuration file. The gate pipeline is very similar, but it's a little more complicated. Here we're saying patches do depend on each other, so make sure that you pay attention to both Git dependency order and the virtual serialization that I talked about. In our system, patches get added to the gate pipeline when somebody leaves an approved vote on Garrett. That's included in the comment added event, so that's actually what we're triggering on. We have success and failure as before, but this time more so. We leave a +2 or -2 vote, which in Garrett mean +2 is actually required before a change can merge. A -2 prohibits a change from merging. Submit is Garrett speak for actually merge the change. So basically on success, vote +2 and then merge it. There's another section here that says when you start running changes, leave a vote of 0, and that sort of clears out the whatever vote might have been left there before by either the check pipeline or a previous run on the gate pipeline. We have a post-merge pipeline. Again, those changes are all independent. They don't affect each other at all. But in this case, what we do is we run on a ref updated event, but only if the ref that Garrett gives us doesn't start with refs, which is a weird Garrett speak way of saying only run this on branches, because for some reason Garrett strips refs branches when it sends you a ref updated event. But it doesn't matter. Zuul doesn't care. We just tell it what regex to match against. And so what we do with this pipeline is we run the documentation, build jobs, and things like that. When I was writing Zuul, I was about to go in and add something to make it so that you could run jobs and not have them report back to Garrett. So basically run them silently. And at that point, that was when I realized that we actually had enough building blocks that we could start to build these things without actually having to modify the code. Basically, if you want a job to run silently and not report back, you just set up another pipeline, trigger it on whatever event that you want, and then just leave off the success and failure sections. So what we do with this pipeline is we put jobs in that we're developing. So if we're working on a new test and we don't have a lot of confidence in it yet, but we want to see how it behaves when we point the fire hose at it, we add that job to the silent pipeline, and it gets run a lot, but nobody sees the results unless they go looking for it. So, another one that we do is the publishing pipeline. So we actually have, for a number of our projects now, we do tag-based releases. So when somebody tags the project and pushes that tag up to Garrett, it runs the job in the publishing pipeline, which might build tarballs and upload them to upload the SDIS to PyPy and things like that. So in this case, what we're doing is we're matching on ref updated again, but we're matching on refs tags something. So once you've defined your pipeline, you can set it up for your projects. We have this section in our configuration file goes on forever, but here's an excerpt from it just for the Nova project. Here what we're saying is that first we want to check if the change can merge. Assuming that's the case, run the PEP8 jobs, the unit test jobs, and the DevStack jobs. So that sets the jobs that get run during the check pipeline. This sets the jobs for the gate pipeline, and then these are the jobs for the post pipeline after a change is merged. Yes, in the front.
I was just trying to understand how the you're checking for style you mentioned earlier. So presumably some of those that
PEP8 checks for Python style.
Okay, so how are you checking the code for style? I mean,
so PEP8 is a tool that checks that things like indentation and line wrapping and things like that match the PEP8 style guide. So in Python, the standardization process for extensions to Python is the PEP process.
Right.
PEP number 8 is, hey, how should we recommend people write their code so that we can all read it easily? So PEP 8 is the name of the standard that defines that. It's also the name of a tool that checks whether code meets that standards and then occasionally then some. And so that's what we're doing here. We run the PEP 8 tool to check if Nova meets those style guidelines.
Okay, thank you.
This is actually slightly out of date. We don't run these merge jobs anymore. At this point, Zuul itself tries to do the merging and decides whether something is going to be able to merge or not. So that actually speeds things up a little bit. But we still have the ability to run a job, and only if that job succeeds, run other jobs, and we still use that in other places. So earlier when I cited Nova and Keystone as examples of projects that have this interdependency, Zuul automatically figures out that interdependency by looking at what jobs are run for the different projects. So both Nova and Glance run the Gate Tempest DevStack VM job, which means that what Zuul deduces from that is that they have they both are required to run that job. They are both used in that job, and therefore they have a dependency on each other. That means that they should share a change queue. So when Zuul reads its configuration in, it analyzes these and finds these jobs and says, in this case, Nova and Glance are going to share a change queue because they depend on each other in that way, and changes to both projects will be serialized together. If two projects don't depend on each other in this way, then Zuul will give them their own change queue. So if you have a smaller project that has no relationship to anything else, then changes to that will go through its own queue, and they don't have to be held up by the longer running changes for the larger projects. So here's a screenshot of a status view. Let me actually see. All right, here's the current Zuul status for the OpenStack project. We have a couple of changes in the check queue right now, but nothing in the gate queue or any of the others. But you can see that once somebody uploaded this change a few minutes ago, and we've actually had time to run through. Yes, this is live. Oh boy. So we've had time to run through some of these jobs already and get success reports. The only thing that hasn't reported back yet is the full run of the Tempest job for this change. This one is obviously a bit more recent and actually hasn't gotten any feedback yet. All right, and John. I just clicked the button. John just approved a change to Swift, so it's gone into the gate queue over here, and you can actually see the change queue. So Zuul has decided that all of these projects in this black box here need to share a change queue because they all run the Tempest test suite. So.
The 20497 is my A.
Oh. Well, hey, I passed PEP 8.
This could be embarrassing for you.
I'll just switch back to the screenshot that I have. So when changes, the screenshot was back from when we had a lot more red on the page, but to me, that reminds me of when I get a paper back from my teacher and it's got lots of red ink on it. So the current status page doesn't have quite as much red on it. But anyway, this is what it looks like when changes start to stack up in the gate queue. We've put in these little arrows to indicate that this one's at the head of the queue, this one's behind it, this one's behind it, and so forth. So once all of these finish, they'll merge more or less at the same time. It'll start working back from the head of the queue once this job were to finish reporting back. I don't know if does anybody here run Jenkins for their projects? Okay, then I'll talk just a little bit about the Jenkins API and how we're using it. The Jenkins API is pretty easy to use. It's a sort of REST API that gives you JSON back. You can use it to configure jobs, look at views, trigger builds on jobs, change build descriptions, cancel builds, look at the build queue, as well as configure nodes. So you can add new Jenkins slave nodes or take them offline. And we do a little bit of all of this in various systems of ours. Since Zuul's in Python, we use the Python Jenkins library, specifically the Python-Jenkins library. It's as easy to use as you'd expect it to be. You tell it, I want a Jenkins object, here's the URL, the username, and the API key. And then you can just call build job, give it the name and the parameters. And that's all it takes to trigger a job build. What Zuul does right now to get results of jobs is we use the notification plugin. That's a little bit more involved. It means that we have to run a little HTTP server, but that's not very hard in Python. So we have a little WSGI compliant HTTP server in here. But basically what that does is in all of our jobs we configure a notification endpoint saying report to this URL when you start or finish a build. And so the information we get back from Jenkins has the build URL, the status, what phase it's in, the parameters, the build number, things like that. All the information that you'd need out of Jenkins to know what's going on. As of yesterday, somebody on our team got a 0MQ plugin for Jenkins working, which sounds like a way cooler way to get notifications back. For one, it means that we won't have to run, we won't have to configure notifications in all of our Jenkins jobs. We won't have to run an HTTP server, though of course then we'll have to figure out what to do with Zuul's status page, since that's overloading the HTTP server for that. So yeah, we might actually start porting Zuul to use that instead of the notification plugin. I expect that we'll import the 0MQ plugin into our infrastructure environment, and you'll be able to find it on GitHub with all the rest of our software real soon now.
I mentioned Clark will probably port Zuul to 0MQ by the time we get back to the US.
Quite likely. So Zuul is located here, github.com, OpenStack-infra/Zuul. The OpenStack infra org is where we keep all of the other really exciting things that we work on that we think that probably people looking for OpenStack aren't actually looking for. Has a Launchpad page. We host the docs for it. It's actually documented, including the configuration file format and everything. It's crazy. Hop onto Freenode and jump into OpenStack Infra if you want to chat with us about it, or send an email to this mailing list. Also, all of our slides are available here at the increasingly lonely OpenStack CI org in GitHub. So, John, another question.
So what's the significance of the name Zuul?
It's a gatekeeper.
That was the best response ever from the audience.
Thank you. Any other questions? Yes.
I just want to say thanks.
Oh.
You're awesome.
Well, thank you.
We have 5 more minutes.
So, you know, if I wanted to integrate Zuul into our work, I can think of a few problems to come along the way. I mean, there'd be some cultural problems to overcome. There'd be you know, people don't like their code being criticised. How does the code review process actually? It's the Gerrit does the. How does that work? It provides a web interface or something, and you see the code in the web page, and then there's places to type comments, or you know, or just you give it a tick or a fail, you know. I mean, so what's it look like?
Yeah. So here's a change that I wrote to Zuul last night and submitted this morning.
Yeah.
And this is to fix a long-standing missed optimization opportunity, which is when somebody uploads a new patch set, Zuul should notice that and cancel jobs for the older patch set since it's no longer relevant.
Yep. Yep.
So here's the git commit message.
Yep.
Here's where Jenkins says, hey, this passed Zuul's unit tests. Of course, as you'll see in a moment, the fact that it passed the unit tests means that the unit tests are not quite comprehensive enough yet. Clark reviewed it and gave it a -1 because he found a problem with it. Here's all of the files that were changed, and you can look at them, and I'll actually show you Clark's inline comment so you can see why he gave it a -1. Over here, he said, hey, you know, you're calling this remove change thing here, but it's only in the dependent pipeline manager. Shouldn't it also be in the independent pipeline manager? And of course, he's right. So there's a bug in my change that I applied this to you know, the dependent change thing, which is the more complicated one, but not the independent one, which is the simpler one. So you know, I need to go back and revise this change. But you can see, you know, side by side the diff between the old and the new versions.
Okay, so
and then back here on this page, you can see all of the comments that people leave on it.
Okay, that's. I mean, it's if the code was written in Perl, would it be able to? I don't know. Is there any kind of language dependency in the kind of code that you can review with it?
No, Gerrit doesn't care. It has a syntax highlighter built in.
For Perl as well?
I don't know. It has, yeah.
It's using a general language highlighting program.
Yeah, so likely if the language that you're working with is a language, it's probably in there.
Yeah.
If it doesn't work, then you might not actually be programming in a language. So.
Okay.
Thank you.
Zuul is similarly agnostic, of course. There's another question in the back.
So who was it?
So what's the reason why you went with not using GitHub pull requests as a review mechanism?
Well, Monty took an hour to explain that on Tuesday, right?
An hour.
Right, yeah. But so the short version is that we have a lot of developers submitting a lot of changes to a lot of projects, and GitHub's workflow around managing, you know, a lot of pull requests from a lot of random people that might be going through lots of iterations in review isn't really up to the level that we're scaling to. So as a reviewer, you would likely be overwhelmed by the number of outstanding pull requests. There's no Gerrit could do a lot better than this, but at least it's got, you know, there's some amount of organization here. So, you know, here Gerrit is trying to show me these are things that I should be reviewing. Down here, these are things I've already reviewed. That sort of thing. So it's trying to help out a bit with the workflow and present things that, you know, basically it's got an idea of workflow built into it.
With the legacy enough, you can actually essentially color pull requests to say whether they passed various levels of things.
Right. Unfortunately, you can't change that, and those things change a lot for us. So another thing where GitHub wasn't quite sufficient for us was in the status reporting. So here, if you've got a change where people are voting on it and it iterates over time. It'd take me a minute, sorry, to find an example that's a little more comprehensive. But you can imagine,
we're of time.
yeah, you can imagine that as people review and change how they think about a patch, that would the votes up here are going to change back and forth as things go on. So we needed a way to be able to see that and to see at a glance, have enough core reviewers looked at this for it to be merged, that sort of thing. And there isn't really a good way to do that with GitHub other than just reading the whole thing, and that can get quite long in our situation. And I'll wrap it up.
Okay, thank you, James. Here's a gift for you from us at LCA. Thank you.